Example number 4. In this one, we're given an isosceles triangle. So if you guys remember what isosceles means you have two of the same sides. And they do tell us that. They say in triangle KLM, KL is 20 centimeters. And then LM is also 20. So that also tells us it's an isosceles. And the base over here, this longer side, is 30 centimeters. Now, first of all, first part, can you use SOHCAHTOA in this triangle to find the measure of angle KLM? So they want us, if you draw it, it's the middle one right here. Can we use SOHCAHTOA here since we know all three sides of this triangle? The answer to that would be no, because KLM is not a right angle triangle. So remember that SOHCAHTOA, the trig, only works when you have a right angle triangle. So how will we find this angle L? So the strategy to that one is to actually drop an altitude, meaning a height, right down in the middle here. Okay. So now, because it's an isosceles triangle, we know that these two sides are the same. And if you remember, the angle, the base angles are also equal. And then this is a shared side. This is an angle also 90 and 90. You can see that this is a congruent triangle. So that means these triangles are congruent. They're exactly the same. They're copies of each other. Which means this side is equal to this side. If you have this entire side to be 30, it would mean that each side is 15 and 15. So we don't need to keep proving this. This is something that you can take as a given in math, that if you're given isosceles triangle and you draw a height in there, it will split the bottom side into equal parts. It's true in isosceles. It's also true in equilateral because all sides are same. So obviously these two sides are also same, that it will also split its the bottom line. But it's not true for scalene. If it's not that a triangle which any sides are equal, in that if you try to draw a height, you can clearly see that these two sides are not equal. So we can only make that assumption between isosceles and equilateral triangles, that if you draw a height from the vertex down to the opposite side, then this side is now split into two equal triangles. So what we're going to do is we're going to focus on one of that triangle. Okay, so one side of them. Let's call this point O. No, let's not call it O. We'll get confused between opposite adjacent, right? Let's call this point P here. So if I just take this one triangle, one side, K, L, P, I know this side is 20, this side is 15. I can find this angle. The strategy is find this angle, and this angle will be exactly the same. So we can combine them to find what we were looking for, which is angle KLM. Okay, so in this triangle, this is my hypotenuse, this is my opposite, this is my adjacent. So I'm going to use the sine of this angle, which is going to be opposite over hypotenuse. And then do the anti-sine to find my angle there. So X will come out to be 48.59 degrees. So you have two of them. So that means angle KLM is 48.59 plus 48.59 degrees. because there's 48.59 here, and then there is 48.59 here, or you can times it by 2. So altogether it should come out to 97 degrees. So that's my final answer here. So make sure you do the questions in here. So this one is going to be, has a little bit more word problems in here. So make sure you try a lot of word problems so you get used to the wording and setting it up. But the main idea in this lesson was to find the angle, and the angle is always done by using the anti function.